Okay, today we're going to be talking about the intermediate value theorem. This is a very important theorem in calculus, so you need to make sure to memorize this word for word, this part up here. Okay, memorize that word for word. That will be on your quiz tomorrow to know that word for word. If f is continuous on the closed interval a to b, and k is any number between f of a and f of b, then there is at least one number in the closed interval a to b such that f of c equals k. Okay, word for word, that entire thing. On the quiz tomorrow, then, there will also be an application problem, kind of like there's example 8 and 9 that are down here at the bottom of the page. So make sure you can do those as well. All right, let's go draw a graph to go with this so that it'll make more sense. I'm actually going to do two different graphs. Here's the first one. It looks, let's just do like, I don't know, a basic, let's say we had a basic sort of a parabola. Okay, and somewhere this is going to be continuous on some closed interval a to b. So I'll just pick some a and some b, and it's obviously continuous in that closed interval. And k is any number between f of a, so here's f of a, and here's f of b, and k is any number in between those two. So somewhere in here is some k. Okay? And we want this theorem tells us that there must be at least one number inside this interval on my x-axis here, such that f of that c, wherever c is, that f of c is going to equal, pretend that those match, that k. All right? This is why it's called the intermediate value theorem, because it's intermediary between these two values, and the f value is intermediate between those two values. Okay? What about another graph? This was function f. Let's do another graph, like take a trig function, like a sine or a cosine graph that has some repetition to it. Okay, something like that. And again, we have an interval, a, to some other interval, let's pick b somewhere else. Okay, and again, I've got f of a, and I've got f of b. Okay, the intermediate value theorem says, again, that there is at least one number in between a and b such that f of that c is going to equal k. Now again, let's just pick a k value in here. So where is that k value? Well, here, that gives me a c, right? Here, it gives me another c, and here it gives me a third c. So really, in this case, I have three values, and that's where the theorem said it gives you at least one number in that closed interval. This is an example of three numbers where that k is equal to f of c, and that's just because of the repeating periodic function that we have there. Okay, let's look at applications of this now. So if f of x were given this nice polynomial, use the intermediate value theorem to prove that there is a real number a such that f of a equals 100. Okay, first step on these always is to show that f is continuous on the closed interval a to b. Well, the first step then is to say, yes, f of x is continuous, in this case, everywhere, because it's a polynomial. And we know from yesterday's lesson that polynomials are continuous everywhere. So that's step one, okay? Next step, what I want to do is I want to go through and find some values here, such as, I don't know, let's just start picking some. F of 2, if I plug in a 2, what do I get? Let's see, we're trying to get to 100 here, right? So when I plug in a 2, again, you can use your calculator, work this guy out, you should get -7. All right, so we need to go bigger. Let's try f of 5. All right, again, we're trying to get to an f of a that's equal to 100. And basically what we're looking for are two numbers that are going to be on either side of 100. One less than 100, one greater than 100, right? So when I plug in a 5, and again, use your calculator, work it out, you should get 26. Okay, so we're getting closer. Let's try 6. Again, using your calculator, typing that all in, you can use your store function. You should get 69, and then f of 7 gives you 138. So that's the interval I'm looking for right here, right? So basically what I see here, f of 6, right? So since f of 6 is less than 100 and f of 7 is greater than 100, right? Then the intermediate value theorem says there must be a C, well in this case they said A, but it doesn't really matter, same idea, right? C such that, right, f of C is equal to 100. And C, by default, must be between which two values? It must be between 6 and 7, right? And C must be in the closed interval from 6 to 7, right? So it's somewhere between 6 and 7, and that'll give you a value of 100, because 100 is between 69 and 138, okay? Let's look at example 9. Similar example, right? So, sorry, that was step 1. This would be your step 2, okay? Again, this one now wants us to use intermediate value theorem to show that this polynomial function has a 0 in the interval from 0 to 1, closed interval. Okay, so first step again, is f of x continuous in that interval? Well, f of x is continuous everywhere in this case, because again, it's a polynomial. Okay, so that's step 1. All right, let's look at some values here. Let's plug in 0 and let's plug in 1, right? So let's look at f of 0. When I plug in 0, I just get -1, right? And let's look at f of 1, okay, which are my two ends, my a and my b of that closed interval. When I plug in a 1, I get 1 plus 2 minus 1, and so I just get 2. Notice, what am I looking for? I'm looking for when it has a 0, right? So I'm looking for when is it equal to 0. Well, since this, right, is less than 0, negative, and 2 is greater than 0, then there's got to be something in between here that is equal to 0, right? So there has to be a 0, right? We're talking about the root of the equation where it crosses an x-intercept. And so we can say, since f of 0 is less than 0 and f of 1 is greater than 0, there must be a c in that interval from 0 to 1 such that f of c equals 0, right? Such that it is a 0, right? And that's it. That's the intermediate value theorem. So again, for the quiz tomorrow, you need to have that first part memorized. You don't need to draw the graph with it. You just need to know the words up there at the top of the page. So those words, write that whole thing. And then you need to be able to do an application problem like either examples 8 or 9 here. And you're going to get to practice a bunch of these now on the assignment.